all learning the basics. We are also going to learn something about inheritance and polymorphism. These are big words, but then I don't think. Can you see my screen?
Yes, please.
Yes.
Okay, cool. So we are going to discuss something about inheritance and polymorphism. These are big words, but then they are not anything serious. That's it's just the name that is big: inheritance, polymorphism. But then we all understand inheritance. So I'll just throw this question on the floor, and if you have anything to explain about inheritance, what will you say if someone asks you, what do you understand by inheritance? What will you say to the person?
Okay. Please, can you hear me?
Yeah, I can hear you.
All right. So I think that the inheritance will be like probably a block of code that inherits its properties or its properties from other block of code or other method.
Okay, so I want it in lay terms when we say inheritance, like normal daily.
Succeeding something from that something that belongs to, or that was at first it was for someone, and then now you are having it, even though it wasn't originally yours, but you, because of a relation that you have with the person, you have it now. I don't know how to put it.
Okay, that's great. Any other person to also give his contribution when we say inheritance? Any contribution? Okay, cool. So when we say inheritance, as he said, please, your name again.
Pardon?
Your name.
Okay, I'm Bright.
Okay,
KBY.
Okay, great. So as Bright said, when we say inheritance, we all understand inheritance when we are succeeding someone and taking up probably his properties or something, and make sure you look over someone's property. We all know inheritance. So some people have got mothers and fathers, they inherit their properties, and it's the same thing in programming as well. So it's the same concept. That's why they gave it inheritance. But then let's say if your father had a car and he was driving it as a private car, when he inherits the car, you can choose to use it as a private car, or you can choose to use that car as a commercial car. So if you, the moment you use that commercial car, it means you've changed the purpose of the car, and therefore that's where we have the polymorphism. So it's like the usage of the car has now been changed. So initially it was serving as a private car, but now you are changing the purpose to, let's say, a commercial vehicle, and you can use it for Uber, you can use it for like a taxi, anything. So it now becomes polymorphism. So that's the term polymorphism. So it's like poly means, you know, we have mono. Mono means one, di means two, poly means like plenty, more than two. So you can change it to different usage of usages. So when we take inheritance and polymorphism, that's the whole concept, and we are going to take that concept and bring it into programming. So let's do some few recap of what we learned last Friday, last Monday, and also last week on Friday on the classes and objects, and also the methods, method overload, and other stuff. So we know that a class is like an object. Let's say a blueprint of something. When we say a blueprint, like let's say a copy of it, just a similar copy of something. So when we say classes, the moment we say classes, we are also referring as objects. Or in actual terms, let's say when we come to this word, we say entities or something that stands for something. So if, let's say, you have human beings, we have, let's say, a car, anything that you can think of is an entity on its own, or is an object on its own. So human being can be an entity, human being can be, a car can be an entity or an object, a pen can be an object. So in programming, we don't call them like entities or something, or we call them classes. So we can have a class, we can have a class, and every class has also got something called fields, or things that a class can do. So when we take human being, for instance, we know what human beings can. A human being can walk, a human being can talk, a human being can jump or run. But when we take, let's say, another class or another entity like a bird can fly but cannot talk. A bird can walk. So we have all these features, and these features, that's what we call methods in programming. So when we take the mother entity, which is we refer as classes, the things or the actions that the classes or those entities can do, we call them methods. But then when we come to the things that we use to identify these classes, so a human being has hands, he has legs, head, eye. These are things that we call the features or the fields of those classes. So in real terms, so for example, in real life, a car is an object, and this car has got attributes such as weight, it has got color, it has got, and these are the things that we call the fields in programming. And the things that a car can do, we call them the methods, such as you can drive, you can brake, you can put on the lights, like you can play songs. So those are the things that we call them methods in programming. So let me just switch my screen to let's look at this. I remember last week or last Monday. So let's look at this. So if you want to create a class, we want to create a class. Let me create a new class here. So this is how we create a class. So you just do your access modifier, or you say either it can be public, your class can be public, it can be private, or it can be abstract. So last, I remember Amos took you through all those things. So if you make it public, it means this class can be accessed by any other class or any other entity. So if, let's say, a car is a public car, it means a commercial vehicle and anyone can just board that bus and just take it. But if it's a private car, it means no one can have access to that car unless the one who bought it himself or herself, who can just be driving his car only. So we have those modifiers, which we call the public or the private, or is abstract, but abstract you go there later. And you just bring the keyword class to denote that it is a class that you are creating, or it is an entity that you're creating. And you just give it a name that, okay, this class, the name of the class is called students. So I can likewise have, let's say, private, I'm just defining a new class over here. So I can say private class, and I'll say person. So that's the name of my class. And that's it. So this should be another class. So this is how we create class, and it's very simple. You just give, first of all, you specify the modifier, which is private or public, abstract. Then you bring the keyword class, and you just give it a class name, and you just open this curly braces so that it will mean that you have this class. So this is how we write a class. That's very simple. You don't do any other thing just by doing this, bringing a keyword class. You can ignore the public and it will still behave as the default one, which is the public. And so you want to create a class, you just bring this class and you specify the name, you bring your curly braces, and that's all. That's how we create a class. Any question on how to create a class?
No, please.
Okay, cool. So we come to the, let's say, a student. A student has got, let's say, a name, right? So we can specify that this name, which is a string. Let's say a student has got, let's say, a course or program that a person is doing. And these are the things that the students, we call the fields or the attributes of that class. So if you want to specify, you create a student, you specify the attribute of the class, let's say the name and the course. So these are the things that you can do, or you can have multiple attributes in here. So this is how we create them. Likewise, if you want to create methods or things that a student can do, so the student can learn, so you can just do public void, I'll say learn. And for methods, we always bring this parenthesis before them, unlike this one where we don't have any parenthesis. But that's why the moment you bring parenthesis and open this curly braces, and it means you've created a method. And that's simple how to create a method. So you can have as many methods in a single class. So I can say a student can learn, a student can, let's say, write. Come again? So these are sample methods that a student can have, and this is simple. So if you want to create a class, you create a class, you specify the access modifier, and so you have the access modifier. You just specify either public or private, and now you can as well also specify your fields in here. You can create a lot of methods in here. So these are how we create methods, and that's it. Any question before we move on? Okay.
Please. Hello.
Yeah. Hello.
Yes. Can the method be created outside the class?
Nope. Okay. Let me ask you this question. Can you have, let's say, a human being, or can you have a hand without a human being, like the person? Or can you have someone dancing? Or have a dance without like anyone being associated to? So it's like a dance can happen unless there's human being or someone dancing. So you can't have the method outside the class, which is it's not possible, because you should have like the entity over there, which is, let's say, the human being or any other object before the method comes. You understand?
Okay, and then can a method be called from another class?
Yes, for that one it's possible.
Okay, thank you.
Great. So you can have methods in different classes, and you can call those methods in also your class and use them. Okay, great. So we can move on. Okay, so we've discussed the methods, and for every method, we need to bring that parenthesis before the method, as we saw. So that's how we create methods. And this example of a method, which is, let's say, calculate area. So we have a class here called a square, and we have a method inside a square. Let's say calculate area. And you bring your parentheses, you open your curly braces, and you write whatever code you want to write inside that particular method. So it's like every method has got a particular thing that a method is doing. So every method has got a course or an aim that is trying to achieve. So in one method, you need to make sure that the name of the method there is doing whatever it's doing inside. So if you are saying calculate area inside a method, you should always calculate area. It should not be displaying, let's say, images, or you should not be calculating, let's say, like summing up or doing other thing. So the name of the method should always be the descriptive enough for the person to know, okay, whatever is going on in the method is what the person has given the description as the name of the method. So when I say calculate area, inside the method, I should be able to see only the calculation of area. I shouldn't see any other thing over there. In programming, we have something called the solid principles. Probably we might learn them later, which the solid, which the S means single responsibility, which talks about every class or every entity being responsible for whatever he or she has to do. So let's say if I take a square, for instance, a square, or let's say if let me come even to the method. So the method is calculate area. It should be able to do only that particular feature. You should not combine a lot of features in that particular method. So that's a single responsibility. So every class should have like that single responsibility, and it should do that only, and you should not be combining a lot of codes inside just one class, which I think is a wrong thing that normally programmers will do. So we move on to today's topic, which is inheritance. And inheritance, we are going to have entities. So let's say I have like a car, or let's say I have entity, let's say the mother or the parents, and this parent has got car, he has got mattress, he has got rooms, fans, and me, the child, I want to inherit those things from the parents. How am I going to do it? So the moment I inherit those things, it means automatically I have access to the things that my parent gave to me. So if it was car, I have access to the car. I can use the car. And since it's now for me, I can use the car to do anything I want. I can change the main purpose of the car. If it was a private car, I can use it for commercial purpose. But then some of the things, when you inherit them, you can't change them. So it's like, though it has been given to you, but then you can't change anything in it. You just have to use it as it is, and we will get there. So some of the things you can change them, some of the things you cannot change them. So some we have some keywords that we use that that denote all these particular changes. So when we talk of inheritance, it allows for one class, that's the child class, to inherit all the fields and the methods. So we've discussed fields and methods, so we know what fields are and we know what methods are. So when the moment you inherit a parent class, all the fields in that particular class and all the methods in that class, you can use them depending on the modifier that has been used in the parent class. So if it is a private modifier, then it means you don't have access to it. You can't use it in your system. But then if it's a public or protected, it means you can use it. So we'll be talking more of public, we'll be talking more of like protected. So for instance, we might want a child class, let's say a dog. You know, a dog is a type of animal. So we can have a class, which is the parent class called animal. And this animal has got a lot of traits and other things. And we can have the child class, which is dog. This dog also will have other traits, but then the moment he inherits the animal class, it means he's going to inherit a lot of things from the animal, and he can start using those particular features or fields. So when defining a child class in Java, we use the keyword extends. So if I want to, let's say, inherit something from my father or my mother, the keyword in programming that we use to inherit is extends. So it means I'm extending the features for my father or for my parent class. So the keyword that we use is extends. So go to a sample class. So let's look at this class. There's a class called animal, and this animal, fine, it has no fields here, it has no methods in here. So the moment I create another class called dog, and I use the keyword extends animal. The keyword extends means I should be able to now inherit whatever the animal has into this class. So even if the animal has got, let's say flying, and I extend it here, this dog should be able to fly automatically because the animal has given me, because I'm extending the animal, it has given me this opportunity to be able to fly. So as I said in the solid principles. One of the principles also will tell you that when you are doing these kind of extensions, you should be careful, because if an animal, I give you a method called fly, and the dog is able to extend this fly method, which means this dog will automatically fly, which is false, because a dog cannot fly. So we got something called Leskov's substitution, which is one of the principles which you need to also check, that the method that you are extending, is it going to be applied to all the subclasses or applied to all the child classes which are going to inherit the main class. So we have another way of going about this, where you can use some kind of interface and other things to do that, but then we are not there yet. So we limit ourselves to this inheritance. So this class, animal, is the parent class, and the dog is the child class which inherits the animal using the extends keyword. So I think we can quickly go to our code and just have sample code in there. If you have questions, you can just bring it up before we move on. So let's quickly, can you see my screen? Can you see the screen for the editor, from the editor?
Yes, please.
Okay, great. So let's have let's create a sample class. So let's call the animal.
Hello. Hello.
Yeah, hello.
Yes. Please, I have a question.
Okay, cool.
Yes. Looking at the explanation, does it mean that in inheritance there should be a hierarchy where the lower or the one down there will inherit the one up there? For example, as you said, animal and dog.
Yes.
Is there a situation whereby somebody at the lower level can somebody at the upper level inherit something from the lower level? For example, if a father inherits something from the son, is it possible?
It's though you can make it possible, but then that's not the order, because in real life situation, the father cannot inherit the child, because automatically, though there are rare situations where, let's say, the son can die and probably the father has to inherit the child, but then it doesn't happen that way. You understand? So the ideology here is, for the parent class, we have the parent class, always the child class will always inherit the parent class, not the parent class this time trying to inherit from the child class. In this case, it's going to be like a boilerplate code, like something that is not usable anywhere. You understand?
Okay.
Yes. So if I take animal, for instance, and you want animal to inherit dog, it means whatever feature this dog is having, all animals are going to have it, which is false. You understand? So I can say, yes, for animals in general, let's say animals can walk, which is true. Now I can also say animals, some can fly, which is true. I can say some animals, some can talk. Sorry. You know, human beings are also classified as animals in science when it comes to science. So we will go by that. So let's see. Walk, fly, talk. And now, if I create another class, which is, let's say, a dog. And this dog, this is a new entity, or this is a class which has nothing. And I want to inherit things from the animal, because a dog is a type of an animal, automatically it has to inherit. We use the keyword extends and we call our animal class here. So automatically, this dog has, or the moment you use extends, it means you are inheriting everything from this animal. So a dog now can walk, a dog now can fly, a dog now can talk, which I said in real life thing when you are doing these things, for the purpose of this teaching, we will limit ourselves to this. So, but then in actual programming, if you don't want the dog to be inheriting these walk, fly, talk, and other things, we have other ways of going. That's why we have the solid principle that we follow. But for the purpose of this teaching, we will just consider it to be normal thing, so we'll go our way. So it means the moment we call dog, so let's say in this animal, let's say in the walk, let's say system.out.println. Let's say I am walking. Say I'm flying. Okay, here to I say I'm talking. So the moment we want to, let's say, let's go to, sorry, okay, let me delete these classes. So we go to our main app and let's call this here. Let's call the dog over here. So you remember how we instantiate a class? Who can help me to instantiate this, the dog class? How do we instantiate a dog class? You remember instantiation means creating a copy of this dog class. So we have this dog class here, and we want to create a copy so that we can use it wherever we want to use. That's what we call the instantiation. So how do we create instantiation? Well, how do we create that?
Please, can you come again?
So I want to create a copy of the dog class and use. So I need to I do that.
You use the extend keyword.
Here. Come again.
You use the extend keyword.
Nope. I want to create a copy of the dog class so that I can use. How do I do that? Peter Body, you've raised your hands. Anyone to help?
What I remember is dog is equals to new dog.
Okay, that's correct.
Yeah.
So I can create a dog, and let me say, what's the name of what name should we give to the dog? Let's say Hope. Then we do the new dog. So this is how we create a copy of the dog. So now we have a dog which is called Hope. And now we are going to use this dog. You know, look at this dog. We don't have anything here. We don't have any fields over here. We don't have any methods here. But then we can call, let's say Hope. When we call Hope, we can call, let's say, the walk method. Why can we call the walk method? Because this dog has got no walk method in here, but then we are still able to call the walk method. Why? Can anyone explain?
Because we have inherited it from the parent class.
Okay, that is correct. Because we've inherited it from the parent class, it means automatically this dog has got the walk method. So when you run this code, automatically they're going to have I am walking over here. And that is correct because the dog has inherited the walk. Here we can actually start using it. So likewise, I can call the fly. I can call the what method again was there? I can also call the talk. So these are methods that we can have over here. So that is what we call the inheritance. So the moment I inherit class, I can have access to all these, let's say, methods. So then there's another thing that we also have. You know, with the access modifiers, we've learned about public now. The moment I do this one to be, I change this one to be private. Let's go back to our code. And that was the work. Why hasn't it been underlined? Because the dog is a standing animal and this animal has got work, just that it has been declared private to animal. And we want to use it, but then it is underlined that we can't use it. Why? Sayura, why? Yes, Peter Body.
Yes, because when you declare a class private, you can only call it within the class, but outside the class, it is not visible.
That is correct. So this method, which is work, has been declared private, and therefore it can only be used within this class. You can't use it outside this class. So I was explaining, if this animal is having a private car, and now you, the dog, you've inherited it. Since it has been declared private to only that particular class, it's like it's just for your father alone. So though you've inherited it, you can inherit all the other properties and use them, but this particular property that has been declared private to your father alone, you can't have access to it. But then you can have access to all the other things that your father gave to you. So the moment we use private, it means you don't have access to it. So let's look at another keyword called protected. When we say protected, who can give me just a small explanation? I remember last Monday we said that protected. So this animal has got, let's say, a private car, and it has got a modifier to be protected. Can the dog have access to it? Hello.
No, please.
Why is it that the dog cannot have access to it?
Because it is not in the same class.
Elvis was not well.
The animal is having this method or this particular thing, and it has been declared protected. The dog is inheriting it, all right? Can the dog have access to this, to the work method? Who is here? Dazi.
Yes.
Okay, so the dog can have access to the the protected class called walk. The last I remember they said protected means it's a default. So once it's a default, it's like a public. So then the dog can use it.
Okay, I like your first answer, but then the second part, I would like someone to explain. Okay, cool. So I think we all have some small knowledge about it. So when we say protected, we normally don't use protected, but then we use it whenever we need it. So protected means let me start from
There's
here.
a hand.
Hello? There's a hand raised. Okay. Okay, who is that? Peter Body. Okay, you can talk. Hello, Peter Body, you can talk.
Okay. Hello.
Yeah, we can hear you.
Hello. Yes.
Yeah, we can hear.
When it is protected, I think members within the class can use it, but those outside the class cannot use it. So if dog is part of the class, then they can use it.
Okay, I think I like your answer, but then I think I need to explain further on that. I like your answer. So when we say protected means any class that inherit from, let's say, okay, let me start from here. The public. When we say public means those, even a class that is not even inheriting from this class can even still have access to this fly. So let's look at an example over here. When we go to the app class, I can say animal, let's say animal cow equals to new animal, and I can say cow dots, let's say fly. So with this we have access to the fly because the fly is declared public. So the public, when they declare a method public or a field public, it means that particular method can be accessed by any other class or any other subclasses. That's any child class that inherit that particular class. So a dog, when the moment a dog inherits animal, since it's declared public, a dog can also have access to it. If it is a different class, since it is still public, anyone can have access to. Let's take it like this. The commercial vehicle. You can say, okay, fine, you have a commercial vehicle. Any person, like any person, anybody can have access to that particular commercial vehicle. So whether the person is from Ashanti, like the moment you declare it public, any person can have access to it. But if I say, so let's go to the app here. I can still call cow dots, let's say walk.
There's a hand raised.
Okay, let me who has raised their hand? Ellen Opoku. Okay, Ellen.
Hello.
Yes.
Hello.
Yes, please.
Yeah, I wanted to explain the protected, but I think you've done it already.
Okay, you can bring your submission.
Hello.
Continue. Yeah, you can bring your submission.
Okay, I wanted to say if it's protected, it means it can, like, he inherited, so he can use, like, as in the father and the son. So he has still inherited, so it can be used by the father and the son only. Something like that.
Okay, yeah, that's great. So I like that.
Amankwa, please unmute yourself.
Oh, sorry. I was muted. Sorry. So let's look at this. When we say protected, so the protected means only child classes which inherit that particular parent class can only use that method. Do you get it? So let's say dog. So let's say dog. And now the dog can use the fly, can use the walk, so can also use the talk. So only classes that inherit from that particular parent class can have access to protected methods or protected fields. So when we say protected, it means the method or the field is for the class himself and also for his child classes. So it's like it's just for only people who are within that family, and that's all. So if you're outside the family, you don't have access to it unless it's public. If it is public, then it can be for all other people who are in the family, also not in the family. But the moment it becomes protected, it means it's for only the classes who are like inheriting it, and that's it. Are you okay with it? Okay, cool. Sake of our time, we will quickly switch to our code and move on. So we have another keyword here called overriding. So this is where we'll be talking more of the polymorphism. So when a subclass, or let's say a child class, the moment we say a subclass means a child class. So when a subclass contains a method that overrides a method of the superclass, superclass are normally called a parent class. You can also call the superclass method by calling the overriding distance. So let's switch back to our code and just use that one to explain. So let's go back to our code. So we have this animal, we have this animal to be the superclass or the parent class. And now we are going to, let's say, have this dog extend this animal. So it is now extending or using the things from or the features from the parent class. Now I want to create a walk method over here. Since the animal is already having the walk, so I can have access to the walk. So the moment I start typing walk, I will have this walk over here. And the moment it gives me this, we have some keyword here, override and also super. So override means though the animal can walk, and I have this method over here. So the moment I call this walk, I can override. Override means you can, so you look at this one, say indicates that a method declaration is intended to override a method declaration in a super type. Though the animal has this, when we call the walk, it has this code here that I am walking. But then when the dog inherits the walk, it's like now you'll be given the car. And though it is protected, you've been given the car. Now you can choose to do whatever you want to do with the car. If I leave this super here, super means calling the super class, that is the animal. That's why we have the super. So the super means you calling the animal class. So if you leave this here, it's still going to call whatever the animal is doing, and you have that code over here. But then if we clean this code here from here, and since we have the override here, it means we can choose to do whatever we want to do with this particular method. Since we are overriding, it's like we are now taking over. That's why we have the keyword override. It means you can take over and do whatever we want to do here. So instead of when we call the walk over here, when we call dog.walk. So let me clean this fly. And let me go here and bring this one here. So let's call this our hope dog. And let's run our code. Since the dog is inheriting from the animal class, when we call the walk, automatically it will call the animal code over here, which is say we should print out I am walking, and automatically we have it here, I am walking. Now, when we go back to our dog class, we don't want to be using whatever the animal gives to us, though he has given us the car. We don't want to be using it for whatever the parent gave it to us. So we clean the super.walk from there because we don't want to use it. When you leave it there, it means you want to use whatever it gave to you, like use it as it is. But then we don't want to do whatever the animal was doing. So we can now override and now write whatever we want to do over here. So system.out. Print line, and you see dog walking. So if I run this code, and I say hope.walk, what do you think is going to be printed? Are you going to have the dog walking, or we are going to have the I am walking over here? Yes, Michael. When we call this dog, and we call the dog.walk, the animal has this method walk, and now we are overriding it in the dog class. We are taking over. So when we call that walk, is it this one that we are going to print dog walking, or we are going to print I am walking? Yes, Michael. Okay.
Okay,
David.
please, can I come in?
Yeah.
Yeah, so what, from your explanation, it means that even though the super class is there, but because you are overriding, it
Yes.
will rather call what you have written, the statement you just wrote, it will dog walking instead of I am walking, because of the overriding method you have used.
Okay. So let's run our code and see what code is going to output it. Okay, so we have the dog walking. Since, as he explained, though we are using the animal, but we've called the method and we have this override keyword here, which means we can do what I want to do with that class, that method. And whatever we have here is rather going to be printed, not what the animal gave to us. So this is what we call polymorphism, where you can have, let's say, another animal called, let's say, a cow, and you call the walk, and the cow can also say cow walking. So it's like the same method, but then each child class which inherit that parent class can have like different usages of that particular method, and that's what we call polymorphism. So that's the whole keyword, that big word that we had. So polymorphism is where you can inherit from a superclass and now make sure that you do whatever you want to do with that particular class, and that's what we call polymorphism. So now, if let's say I have this work in the animal class, and let's say I gave it to you, that now inherits walk, fly, and talk. But then I don't want you to make any changes to any of these statements or any of these properties that I've given to you. So I've given you house, I've given you car, I've given you whatever. I don't want you to do change anything. Like let's say I've given a car, and the car, the intended purpose was for you to use it as a private car. And now I don't want you to change it to any commercial or any other thing. We have a keyword that we need to use here. Who can help me with that keyword? I don't know whether it must touch on that. Anyone have an idea on that? No one? Okay, let's proceed. So let's say the work. I want all my children to inherit it, but then I don't want them to make any changes to the work. So you can't override it. It means whatever I give to you is what you should use, and that's final. So then why not we use the word final here, and that's all. The moment I use final, automatically, if you are a dog, you can't override work. So you can use it all right, but then you can't override it to make changes to it. And it's like, and that's it, final thing. So the moment I use final, it's like I've given a final thing, so you can't make any changes to it. So when we go to the dog class right now, it will underline work, that this work cannot override the final method from animal. So it means we can't override work, though we can call the work here and use, but we can't make changes here in it to that particular method, and therefore we can't use it because we declared it final. But then we can still use it all right because we've inherited it, but then we can't make any changes to it. Are you okay with that? Hello? Do you understand that?
Yes, please.
So the moment I will say final to this fly method also, I can't call fly here. You see, I can't even find fly here because I've declared as final. So you can't even find a fly and override. But I can call, let's say, talk, because talk has not been declared final, and therefore I can call talk and I can override and do whatever I want to do over here. So let's look at a simple example over here. Let's say private void. Let's say sync. Can we also call this method? Can we override this method? This sync method. Is it possible for us to override? Yes, Ellen. Is it possible for us to override that method?
Hello.
Yes.
Yes.
Why is it yes? The sync method. Can the dog inherit this sync method? And is it possible for us to override?
No.
Why
No.
Why no?
Because it's private.
That's
And it
correct.
can't be used outside.
That's correct. So we can't come here and say sync. We can't even find a sync here because it has been declared. And when we go here, you can't even call the sync here because it's private to only animal, and therefore you can't use it. Even the inherited class cannot even use it because it is private to the animal himself. So if it is private to your father, though you've inherited it, but it's private to him, so you can't go and use his private car or something. So that's private to the parent class, and that's the thing that we have here: the private, the public, the protected, and also we've learned about the final keyword. We've also learned about the override method. Now let's look at super. We will go back to our slides, but then I'm just using this class to explain all the other slides. So by the time we go to our slides, we are done with all the slides. So let's look at this super. Let's say, as I explained, super means you calling the super class. So let's have another method here, public void. Give me a word. What can an animal do? Let's say dance. Or let's say cry. And let's look at it. Sound of every animal, how they cry. So we will print out the sound that they will cry over here. So let's look at this. So there's a method over here which is called cry. Now when I go to dog, I can override this cry. So if you want to, you know, this cry, this animal here in this method is taking an argument or a parameter. You learned something about arguments, right? Arguments or parameter. I remember Amos took you through that. So you can have multiple arguments over here. You can just use your comma and just be adding multiple arguments. So if you want to pass in sound to this particular method and you want it to do anything that you want, you can as well use the super. So I can call the super here and pass in whichever cry. If the dog will say whoa, I can have let's say another animal, let's say cats. And this cat also extends animal. And this cat also will say, will also override a cry, and also cry, meow. So we go to this class and let's call dog and let's call a cry method, or even let's do it this way rather. Let's call this sound rather here so that we can use it. And likewise, we call it rather from the class, from the main. So let's go here. So I'll say this dog and I'll pass in the wool. I'll also create another animal called cats. And let's say, what's the name of this cat? Let's say peace. And I'll say new cats. So we are creating an instance of another class. And we call the peace. And we also call the cry method also here. So this is what we call the polymorphism. So I can also call them meow. And automatically when we run this code, we are going to have the dog crying whoa, and also the cat also crying meow. So let's run this code. So we have this here. So whichever value that we passed here is going to be different from for both animals, since we've done the override thing and we are also calling the super. So since we are calling the super is also calling the super class cry, which is also doing this, just printing whatever that you bring as a parameter. Do we get that part, or is confusing? Are you okay with this? So that's what we call polymorphism. The moment a dog can override something, the cat can also override the same method and then make changes to it and do whatever they want to do with it. And each of them having different results, but then it's still the same method. That's what we call the polymorphism. Any question? Okay, great. So we've learned about overriding. We've learned about the super keyword, and that is what we just demonstrated. And also, we've also learned about the protected as well as the final keyword, which if you want to make changes, you don't want your child class to make changes to your method, you just declare them as final. And that is it. And we've also learned about polymorphism. It allows a child class to share the information behavior of its parent class while also incorporating its own functionality. So you can still have access to your parent class functionality, and you can also modify it and to suit whatever you want to do. So if you want to leave your parents' stuff over there, you have to leave the super there and continue for whatever you want to do beneath it, and it will also work the same thing. So if we learned about polymorphism, and that is it. Any questions? We have like 19 minutes to close. So if you have any questions, you can bring up. If you have any contribution, you can also bring it up. We have also some tutors here, James here, I think Andy here, and also Arthur here. So if you have any contributions, you can bring it up before we wrap up and close. Andy, George, James, if you have also any contributions, you can also bring it up and we can close as well.
Okay, thank you, sir. Right now, the whole thing has almost ended. This is our last class for the month. So if you have a question, it can be from even the first session, and all the teachers are here to answer you. But then my contribution to what was taught today was the polymorphism. Usually, what my teacher taught me was a class of many forms. So anytime you hear polymorphism, think of a chameleon, how a chameleon changes. At the end of the day, it's still a chameleon, just that the colors is what is differentiating the chameleon. So you can see the chameleon today as red, tomorrow you see it as yellow, today you see it as black, by the same chameleon. So anytime you hear polymorphism, and I'm sure it's not something that when you're coding every day, it comes into your head that, okay, I'm using polymorphism. But then when you go for interviews and all that, you should always try and remember that these technical questions will be asked. So it's not only for your understanding, and you also have to understand the term when you say polymorphism. So it's always a class of many forms, a class that can be used and in another form. So that's the only thing I will add. So anytime you hear polymorphism, try and remember chameleon, how it changes colors, like the same chameleon. Yeah. So yeah. So this is my closing remark for the month January. The floor is also open for other tutors to have their closing remark for the month January before we end the class. Also, we thank you very much for your contribution and your time and always making it a point to join the class. And we like your feedback that you are giving, and we are going to be even better in the month February. We are going to do much better per your feedback you've given to us, and we are going to work harder to make sure you understand. Our aim is to make sure you come out with the skills and knowledge in programming, and also create a career out of what you're learning. It's not just learning for fun. So we want testimonies, living testimonies of people who have passed through the class and have gotten one or two employment out of this. So yes, that would be our joy. So we are here. So it's 9 p.m. The floor is still open. My colleagues, please say something before we end. I don't want to mention you, so I know you're here. So if you know, please say something whilst we wait for our class members to also say something.
Hello.
Hi.
Yes,
Yes.
yes,
Yeah. Mine is not the question, but I want to find out when will the class be streamlined? I remember the last time you said one of the tutors said that when we enter the new month, we won't have a general class like this, but then if it's Java or if you're interested in the mobile dev, you go into the mobile dev. If you're interested in applications or the web stuff, you also go into that side. So I was asking if how is that happening, or